And hello, everybody. Mr. Cowan here, talking you through our learning target for today. This will be for Friday's lesson, March 20th, 2020. Learning target for the day, I will solve problems using the Pythagorean theorem with 80% accuracy or greater. Yes, if this seems familiar, this is a review. After all, we've been working on two-step geometry for a while, and so this naturally fits back in. Most, if not all, math teachers in 8th grade will be reteaching this in the spring. Always start with level 3 to really know the learning target for today. Level 3 says we're going to correctly solve problems using the Pythagorean theorem and be able to explain our reasoning. Of course, you are always welcome and challenged to move up to the next level, be able to describe how to fix problems, correctly determine answers, etc. Level 2, almost getting there, understands a squared plus b squared equals c squared, but don't quite yet know where to put the numbers in or how to solve for the missing length. And level 1, not yet understanding, yeah, we're talking right triangles, but don't know where to go from there. Again, a reminder, we have already learned this way back in the fall. I believe it was toward the end of the first quarter. We even put some notes in our interactive math journals. So to bring you back to some problems, as always, one of the best ways to learn anything, how are problems similar, how are they different? Here we have a right triangle, here we have a right triangle. Well, indeed, they are a right triangle, and therefore we can find a missing piece. In this case, that missing piece is labeled B. In this case, the missing piece is labeled C. But a similarity for both, because they're using right triangles, we can use the Pythagorean theorem. A squared plus b squared equals c squared, where a and b are called the legs. They form the right angle, and they are the shorter of the three sides. Meanwhile, that side C is called the hypotenuse. You can identify it two ways. Number one, it is the longest edge, but to point out, sometimes looks can be deceiving. Sometimes you can't quite tell which is longest. This is actually an example, but you can always identify the hypotenuse by looking for the edge that is opposite of the right angle. So there's a few ways of how these problems are similar. Now let's talk about the difference, and of course the main difference being that for this problem, there is a missing hypotenuse. For this problem, it is one of the legs that are missing. Now that's important because as we set up the formula, we note here C is the missing piece, it is the hypotenuse, while over here, B is the missing piece, it is one of the legs. Meanwhile, the longest edge, the edge opposite of the right angle, is 11. Now in this case, 3 squared is 9, b squared is, well, we actually don't know what b squared is. 11 times itself is 121. Over here, can I just point out, please, that both of those numbers are on the same side. So we can square those numbers, 225, I don't know what that is, somewhere in 300s probably, and then add them up. Meanwhile, we don't want to know what the square of c is, we just want to know what c is. So what number times itself equals 549. Inverse of add is subtract, inverse of multiply is divide, and the inverse of a second power will be the second root. In this case, the square root of 549 is a crazy, ugly, irrational number, but we can round that using our math tools to be about 23 4/10 feet. Note again, that is when they are on the same side. You can simply square them and add them together using your Desmos calculator or other appropriate tool. Here, however, we have to take note that these numbers are on opposite sides of the equations, and therefore we have to use opposite operations. The inverse of adding, or a positive 9, would be to subtract, or take a negative 9. Now 9 minus 9 equals 0. That leaves only the square of b, and thus we are one step closer to solving for b. 121 minus 9 is 112. 10 times 10 is 100. 11 times 11 is 121. So this probably is going to be somewhere between 10 and 11. To get rid of a square power, we'll take the square root and, of course, be fair to both sides to keep that equation fair and balanced. And in this case, again, the square root of 112 is a crazy, ugly, going on forever, non-repeating, non-terminating, irrational number, but we can round it to approximately 10 6/10 centimeters. You know, one thing I forgot, I'm always trying to fix my habits. From now on, really, I should be looking at this problem and making a guess. This is 3, this is 11, this should be smaller than 11. I'm thinking about 9 or 10. Meanwhile, this is 18, this is 15. That looks to be a little bigger than both, so maybe 20. And we can use those estimates, 20, about 23 and 4/10. That was a good estimate. Meanwhile, if we said 9 or 10 and we got 15 or 17 or 117, we know the answer is wrong. 10 and 6/10 is awfully close to 10. Now, if you'd like, I'm going to go ahead, I'm going to complete one of the homework problems, or at least start it up for you, where we notice one of our most challenging problems is given a problem, can we write it in Pythagorean theorem? And of course, I'm a visual person. I'm going to actually draw this out. Forgive the numbers are going to be off, but this is about a pool table. Sides are 8 feet by 4 feet. Meanwhile, they're asking how far from one pocket to the diagonally opposite corner pocket. Now, this is important because now I can see this is where the right angle is, so that allows me to set up the problem. Noticing that 8 and 4 together make the right angle, and therefore those are the legs. Noticing that X is the longest edge, or the side, the edge opposite of that right triangle, that right angle. And therefore now we can go ahead, you can go, I would encourage you to go back a slide to rewind if you need to. Is this problem more like the problem on the left or like the problem on the right? And what would the next steps be in order to solve this and finally find out what X is? Don't forget, make yourself an estimate, make yourself a guess. So to wrap this lesson up, a reminder of where we are heading. Go ahead and kind of self-assess. Do you think you're in the level 3? Do you have it? Are you able to correctly solve these problems? And if so, can you explain the reasoning? Can you move a step up and describe problems, find errors, even determine how to fix errors? Or do you still find yourself, where do the numbers go, Mr. Callan? If so, go to Khan Academy, go to any YouTube site, find some videos, watch some videos, or just email me. I am here to help, ladies and gentlemen.